Hey, Bogdan Brzeski here. Welcome another video, linear functions in the context of rate of change. Using tables, using graphs, we're going to discuss that topic right now. So rate of change is the important concept in mathematics because you surround it in your everyday life. You're surrounded by rates of change, and the most typical connection is where you see the speed limits on different roads, right? You are familiar. If you don't drive, then you can at least see those signs visible on every street that you're walking or you're using. So rate of change application, for example, the pitch of the roof. So this represents the rate of the height to the span of the roof. So the height divided by the horizontal distance represents the rate, represents the pitch of the roof. Another familiar sort of surrounding that you can relate to, you have seen stairs in buildings, houses, you name it. So there's a certain code, there's a certain way of constructing it so that the risers and runs, they have to remain in a certain ratio because the distance or the length of each is determined by the building code. Depending on where you live, code changes, but the rate is always within certain parameters. So once you build, let's say 7 inches over 10 inches, so 10 to 7 would represent rate of change. The vertical height versus the horizontal distance. And when everything is created, the rate of change is constant here, right? So the slope of the roof for a particular section must be the same. Same for the stairs. You probably have seen this. Some of you, depending where you live, there are roads where the hills are steep and there's a warning sign. And sometimes they give you the percent value, like 2%. So that means 2 over 100 rate, the vertical change versus the horizontal change. Flying objects, another example. So over time, let's say this is the timeline, and this is the altitude of this drone. Moving into constant speed, of course. If the speed is not constant, the rate of change is not constant. So that's sort of the introduction to rate of change. The words that we use often interchangeably represent slopes in mathematics, so that this is the most common used term. Then rate of change also. Then you have rise over run, which is a very good connection that you're making with the division statement. The rise, so this is the vertical change over the horizontal change. So hopefully this makes sense now. This hits home. Unit rate, the speed signs on the road, 50 kilometers per hour, 50 miles per hour. The trend in statistics, you can build a line that shows a specific trend. So you can say the rate of change is constant, it's linear, because we're talking about linear function in that context. So the rate of change represents how much one quantity changes in relation to the second quantity. So you're building a ratio. That ratio could be expressed in form of a fraction, a decimal number, a whole number, negative numbers, etc. Percentage, right? But in mathematics, the rate of change is defined as the ratio of the change in one variable corresponding to the change in another variable. So it is the expression, the spread in y coordinates, given that you have 2 points to consider, divided by the spread between the x coordinates. Again, the rise over run, it's very typical application of the concept of rate of change and slope. So for example, when you have 2 points, P and Q, you can appreciate the difference between the index x1 and y1 versus x2 and y2. So that makes those 2 points distinct. They are apart from each other. So the spread in y is the delta, the Greek letter that is used in the symbol of a triangle. So that's the spread, vertical spread between those coordinates y2 and y1. And the spread between x values on the Cartesian plane. So now you start seeing sort of the more focused application of rate of change. And in terms of linear functions, the rate of change is constant. So the quantity that you divide, where regardless how far those points apart, everything represents the constant ratio because there is a linear behavior. So that means you may have a positive ratio, you can have a negative ratio. So you always remember how we read the diagram. You read left to right, and we observe the behavior of the line of the linear function. When the line is falling down, then the rate of change is negative. Occasionally, you'll see that the line is a horizontal on the diagram. So that means you cannot say that there's no rate of change. The rate of change is 0. So that means the time, for example, frame is measuring some object stopped. It doesn't move. So from this time to this time interval, there is a 0 change in altitude in y coordinate. So the object is not moving. It must be in fixed location, fixed position. So because rate of change is a part of the linear function, every time you define a linear function, you are indirectly talking about the slope, the direction of the line, and the y-intercept is the point that every linear function has to have. So more kind of a focused mathematical perspective of rate of change, you have point A has coordinate x1 and y is 2, and point B, x is 5, y is 10. So there is a change in direction, horizontal, and then there is a change in vertical direction. So once we find how many units apart vertically, this is the delta y, the spread horizontally would be measured between 5 and 1. So when you establish the fraction, delta y over delta x, you will say, now I know the rate of change. And then the assumption is that we're talking in the context of a straight line, linear function. So there's no deviation. The change is constantly the same. Sometimes you will see a diagram when they say the fall is defined in terms of the word rise or negative rise. So just be aware of that, that the beginning of the process starts, let's say at this point A with x1 and y10. And then it goes to point B where x is 5 and y is 2. So you have noticed that the run is always measured from left to right. So from x being 1 to x being 5, so 4 units apart. But then from 10 to 2, there was a drop in this case, right? The number of units apart is 8, but this is the negative measure because this is the behavior of the line that is decreasing, right, on its domain. The line is decreasing, so the slope is negative. And this is the typical example where the run and rise is indicated. Instead of calling it horizontal change, you have a run. Instead of calling a vertical change, you have rise, and the ratio, this distance divided by that, represents the rate of change. So hopefully you're getting better and better understanding. Now, table of values sometimes is given, but you have to, as an independent thinker, hopefully you're developing skills to think independently, always verify, you have to observe the following. You have a table of values, right? So the first test that you must perform is to notice that the x values are apart by the same distance, by the same value. If this is a messy column, then this table cannot be used to predict anything, right? Maybe trend in statistics, but in mathematics, we want to make sure that the elements from the first column, the domain, is a range, whether this is increasing continuously by the same number or decreasing, it must be constant. And then you associate each x point has its output, the y values, and then you can sort of establish the first differences. We did the video before. If you have missed that, go and revisit. So the difference is constant, but between two neighboring points. But you can say, what about if I connect point 12 and 3? So then in that case, to build the ratio, you have to connect 3 and 0 from the x values. So those are the examples, the possibilities, not all, but some, that show the difference in y values divided by the difference in x values. Each time you grab any combination of any 2 points, you do the y difference on top divided by x difference on the bottom, and you always get the same reading, the constant rate of change. So the slope, hopefully you know, familiar with this, is expressed as the difference between y values divided by the difference in x values. You may say, can I do the difference in that direction? Yes, but then you have to do the difference in that direction on the bottom part as well. So it doesn't matter how you do. Traditionally, we do the higher value minus the lower value, and then in the same direction you would do that. But if you do the other way around because you feel like doing in opposite direction, do it. But y column is on top. That's the spread in y coordinates divided by the spread in x coordinates at the bottom. So that's the key. So hopefully this makes sense, and practice questions is for you. Because if you're learning something, you have to build a solid foundation. Hopefully you do. Thanks for watching. We'll see you again. Bye for now.